Hello and welcome to a new video on Neil's Retro Hobby Room. In today's video we will build our own Apple I computer. As you probably know, the Apple I was the first computer that Apple built. It was designed by Stephen Wozniak in 1976 and it was a 6502 based computer. And I always wanted to build my own Apple I, and since these are quite expensive today, I thought I built it using an FPGA. Also, some time ago, I bought this very tiny and small FPGA board here, and this is the TinyFPGA board. And the TinyFPGA board is an FPGA chip on that board, and you can, for instance, put it into a breadboard. But since I wanted to build an Apple I, I searched for a project that already created an Apple I using an FPGA, and actually I found one. And I will today build a board using this PCB here. This is a TinyFPGA computer project board. I think it's also part of the TinyFPGA project, and it was built by Luke. And this board allows to put the TinyFPGA onto that board here. I hope you can see that. And then this board offers connectors to peripheral components like a keyboard, a monitor, you have a VGA output, and some other output that you can use, for instance sound. But the Apple I, of course, doesn't have any sound. The Apple I was, as I said, the first Apple computer built in 1976. It had 4 kilobytes of RAM, and it had the WOSMon, where you could program directly in the RAM. And in this video, we will, as I said, put components onto the board, then put the TinyFPGA board also onto that board, and then we will see how we can use this to have our own Apple I. But at first, let's have a look on the desk in detail on the components I have here. As you can see here, we have the TinyFPGA computer project board, and we have here the TinyFPGA board. Actually, this is a TinyFPGA-BX. And what we have to first do is we have to put these pins onto that board, and then we will solder the board itself. I'm back now after a lengthy debug session, and yeah, as you can imagine, it didn't work at first. And last evening I tried to run the Apple I computer on the FPGA, and I programmed it using GitHub projects I found with the Apple I source code for the FPGA. And I compiled it, I uploaded it to the FPGA, I went upstairs to my retro hobby room, and it didn't work at all. I got no picture and it didn't work. So I started a debug session. And at first I found out that the connectors on the FPGA board in that project I used were wrong. So I had to reassign all pins, and I did that, and then I reprogrammed the FPGA on that board here, went back to my retro hobby room, and I got a blinking cursor, but the keyboard didn't work. So I was again a little disappointed, but yeah, let's go on with debugging, I thought. So I went back into my office and went through the source code. And I realized that the keyboard in the source code wasn't enabled. So I did this. I had also to assign the pins correctly in the source code of the keyboard of the FPGA, or of the part that controls the keyboard. I did this again. I reprogrammed the FPGA. I went back up and it worked very well. Another problem I had was that, as I told you, I have a TinyFPGA-BX, but in the source code I first found was only the TinyFPGA-B2. So I had to replace the TinyFPGA-B2 by a TinyFPGA-BX in the source code. I found a fork of the GitHub project and someone already did this, but as I said, I had to assign the pin outs correctly to the FPGA board. And yeah, that worked quite well then. And now it works. And I think we will now have together a look at the Apple I here and see what we can do with it. The first thing you will see when you start an Apple I is this blinking cursor here. And it allows you to enter text. This here, by the way, is the WASMon. It's a small program that allows to manipulate the memory of the Apple I. For instance, you can type "Hello World." I have a typo, and the problem right now is that you can press backspace, but it doesn't work very well because the Apple I uses shift registers for the screen, so everything you type in is in a shift register and can't be removed. So you have to start over again. The nice thing with the WASMon is that you can type in an arbitrary address, for instance 001, and then the computer or the WASMon will tell you what content is in that address. But we can also exchange the content of memory. And this particular Apple I FPGA computer here allows you then to change the font, the foreground and the background. The original Apple I wasn't able to do that, but here with the FPGA, the creators of the FPGA thought this would be nice, and I also think this is really nice, so let's change the foreground color, for instance. Let's first see which color we have. So we have now color 7, and when we enter C001 again for the address, and this was an error, C001, and error again, C001. Now it's correct, we need 2 dots, and then we can, for instance, enter 1. And now you can see that the color is blue. C001 and 2, and it's green. And I think we will keep the green color since it's really nice. We can also change the background. This is C002. We see it's 0 now. Let's change it to 1. And now we have a blue background, but I prefer the black background. So let's change it to 0 again. So what can we do now with this Apple I? Or at first, let's also have a look at the fonts. C000, we have font 0, so we change it to C000 to 1. And now we have another font. But I think to that you can see it better, we use the 0 font. And I keep typing not the correct 2 points. Now we can see again the original font. And you can manipulate, as I said, the memory by entering a start address of memory you want to change, then these 2 dots, and then the bytes as hex values as you would like to change them. And then we can also run programs using the Apple I. The Apple I here uses a 6502 CPU, the original one. Of course, the FPGA also implements the 6502. And I found on the GitHub project of the Apple I FPGA a nice Hello World program. So let's enter this. Now we entered the program, and when we type R, it will run the program. And as you can see, I made a small mistake. The bracket should be an H. That was the last byte, I think. That should have been a C8. I typed in 28. But nevertheless, when you start the Hello World program here, it doesn't return correctly to wasmon, I think. And then it doesn't anymore query the keyboard or listens from the keyboard, and now I can't type. But I can just reset the computer by pressing the reset button here. Now I reset it. And we are back at wasmon. And yeah, this is everything you can do with the Apple I. So you can read out memory, you can write into memory, you can write programs using the opcodes as hex values to the memory, and then execute this like we did with the Hello World program. I saw on the GitHub project that there is a basic interpreter for the Apple I, which is, I think also in the FPGA, I have to look it up how it works. So maybe in another video I will show basic on the Apple I. But I think as a first demonstration of the FPGA Apple I, this is enough for today. Yeah, and this is my FPGA Apple I. I didn't mention that I had a small problem with the PS2 adapter that I soldered, or the DIN connector that I soldered onto the board. The problem was that despite I ordered the correct parts from the BOM, the connectors of the DIN connector are not correctly assigned to the PS2 keyboard that I have here. I found it out by just testing it, and to circumvent the problem that my DIN connector doesn't connect correctly to the keyboard, I put wires onto the board. The board has a lot of through holes where you can use cables to connect other things, and luckily I had in my spare bins, in my spare part bin, this PS2 connector, so I connected the keyboard and it worked then very well. This was another problem I had during the assembly, but nevertheless, I think this is really nice. I have now an Apple I computer on a TinyFPGA chip. This is really amazing. When you have a look at the original Apple I, how many chips they needed to build it, and it was really a cool computer, and today you can fit it on this very small FPGA chip. This is really amazing. Yeah. And yeah, this is everything I wanted to show you in this short video. I hope you liked it. If yes, please give a thumbs up. Also, if you did not yet subscribe to my channel, it would be really cool if you do so. This really helps me to grow the channel and make it more popular. So thank you very much for watching, and see you in the next video.